DJ, what's up?
Look
Look, it popped up and said we're live.
Hey, we are
cool.
live, everyone.
Why is it not?
I think we're live, even though it says we're live. So, hi, guys.
No viewers. Woohoo! What's up, people?
It is switching, it looks like, without me doing anything. I see that we are.
Great.
Cameraman is switching.
Oh, it is switching. Sweet.
Yes.
Sweet.
Okay. Yeah, it's a little delayed, so we got about a 10-second delay, and there's me picking my nose, and everybody gets to see that. So, welcome to Breaking Down Bitcoin, everyone. This is episode 2, where we are really just winging it, and we're going to use the Mastering Bitcoin book by Andreas Antonopoulos.
I gotta pay respect to that man. He is.
Yes. By
far whenever I'm getting down on crypto, you watch one of those guys' videos, you're like, he picks you up again, you're feeling all good about it again.
No,
that man deserves an award.
Definitely, and I've binge watched many of his videos in the recent week in preparation for this.
Oh, there we go.
Oh, you got your audio.
All right.
Okay.
Cool.
It works. So it works. All right.
I think we're up, running. Just no one's watching. We're all good.
We got 2 watching now, which I think is me and you. Yeah.
This is
great.
All right, cool. Well, let's break down Bitcoin.
Okay, let's break down Bitcoin. So basically, in our first episode, we covered chapters 1 and 2, which were an intro to Bitcoin and transactions. Really basic stuff that you can pretty much learn on your own, or read the chapters, or watch our first video where we touch briefly on them. The chapter 3 is where the meat starts, where we actually start diving into playing with the Bitcoin node software, bitcoin-cli, and bitcoin-cli to pull some data from the blockchain.
Do you know what bitcoin-cli is?
The D.
Bitcoin-cli, CLI,
yes.
Right?
Yep.
Bitcoin-D. That's just
the bitcoin-D is the daemon or daemon.
Oh, okay.
Whatever you want to call
it.
It's
the daemon.
Yeah.
It's the service.
Yeah, it's the service that runs in the background. So I'm going to do some talking about this. I have some screen shares that I can do, so bear with us while we figure out this Google Hangouts and screen shares. I'm going to do this, and I'm going to select just my Chrome window, and make sure I change my tab so that way you guys don't see. Okay, so I'm sharing screen.
I don't see our little preview windows at the bottom, but I'm not too worried about it.
Oh, okay. It's probably because I'm hiding myself from the broadcast, which I'm going to pop myself back in. So do you well, we'll see it. We'll see it in a minute. You keep an eye on it. Basically, okay, cool. Good. All right. So to get started with Bitcoin development is probably install a Bitcoin Core full node, which you can actually get from the bitcoin.org website. And you can go to download. I'm not going to take you through downloading and installing this, but it's pretty straightforward, pretty much for every platform. Ubuntu, Linux, Windows, Mac OS. I have an installation in Ubuntu that I'm going to show you some demos on, so it's all command line. But there's also a GUI available for all these platforms where you can actually see and interact with it through a GUI interface rather than through command line. But basically, once we get that installed, it will actually download and synchronize all of the blocks in the blockchain to your machine. So it can be pretty large, about 150 gigs or plus. There are ways to prune that down, if you'd like, to a much smaller size, which you can do. But I'm not going to cover that in this video anyway. But I just wanted to show you basically the node that we're going to be connecting to, which is mine at home. You'll see we're at this web address here, bitnodes21. Let me just see if that's showing up in the live stream here. It looks like it is. Cool. Bitnodes.21.co, and you'll actually see the information for my particular node on the network, my IP address, and all that good stuff. I'm not afraid to show it, apparently. And then there's also a map where you can view all of the Bitcoin nodes in the world on this website as well. So you'll see quite a bit of nodes in the US.
You see mine.
Oh yeah. Where's yours?
Zoom up on Charleston, South Carolina.
All right, there we go. We got 2 or 3.
Oh,
It doesn't have to show near, like exactly where your house is, though. As
it might
long
be
as
in my ISP.
yeah, because mine does not
18.
show. Mine does not show the exact
Okay.
location. Now, if you know your IP address, your public IP, you can search for it, and then you'll be able to see if it's on this list. So
Cool.
as long as it shows up here, it's definitely being used. Mine shows up a terrible latency, which honestly, I don't know where that number's coming from because latency is usually 1 or 2 milliseconds, but whatever. But anyways, it's just interesting. These are all the nodes that are connecting to each other throughout the world. Let's go to the live map.
I think I remember like a year ago there was like 7,000. So
Yeah, it's definitely growing.
I guess it's growing. I'd say, yeah. I don't know if I can grow a little farther than that, but
Oh yeah, and you can see this is a live map of all the ones that are being indexed by bit nodes. And this basically every node has a list of
broadcasting.
What's that?
Those are all full nodes, right?
I'm not sure if they're just full nodes. They're just reachable nodes, as it says here in the Bitcoin network, that are being crawled by the BitNodes crawler. So just this particular website, and as if you don't know, the nodes are what actually have a copy of the blockchain on them, and then do the transaction and block verifications. They don't necessarily do the mining. However, miners can be nodes as well and have the whole blockchain and do verification. And I believe that would be really a true full node, something that actually is mining the blocks and also replicating them and verifying them. But in this case, I'm just running a node to verify transactions and blocks, not doing any mining. So it's not too power hungry. It's just bandwidth and storage hungry. So once you have that installed and you're able to get to a command line interface, you can actually, in the book, it shows you how to just get some basic info from your node or the node that you're developing against. And let me just go ahead and stop my screen share here and switch to another application.
Hey, there you are. What's up?
Hey, we're back. Cool.
I might have to get some headphones because every time you talk, it pops up. My screen pops up, and I'm just like staring at you. Sorry.
That's okay. You can stare at me all you want. But anyways, let's do another screen share here. I'm trying not to do like the whole video screen share, but really the stuff that we want to show, it's best to talk about it when we can actually show examples.
Yep.
So let me just select my screen here and share it again. There we go. Hopefully this is easily readable on a mobile screen. I'm going to try to zoom in a little bit to make it a little easier. Zoom in. That didn't work. Zoom in.
That's nice.
That doesn't work.
Yeah, thanks for the comment about mobile friendly.
Yes, no, that actually is very true. So I looked at the stats for our first video, and it looks like it's mostly watched on mobile. So that makes a lot of sense. Make text bigger. That's what I'm looking for. So you don't have to have a Mac to do this. You can do this on pretty much any OS. I'm going to stop my screen share and start it again because I just made my font bigger. And it should look nice and clean. There we go. So I'm just going to do a clear of my screen. But even in Windows, you can do this from the command prompt. This is just me connected to my node, which is local, just running on a little Intel NUC mini PC. But basically, the commands that we're going to run, let's pull up the list. Here we go. Google Docs. Basically, once we have the Bitcoin software installed, we can talk to it through the Bitcoin CLI interface. So it's just an application you can run, and it gives you, a list of options and help on how to run it. Basically, it sends the command to the Bitcoin core. So in this case, we're going to run a Bitcoin CLI get info, and this just gets some basic info about the node that we're connected to. In this case, the one installed on this machine. And first of all, I'll give you a warning nowadays if you're on version 1 or 0.15 about how the get info is being deprecated and will be removed in version 1.16. So there's actually some new commands you'll want to run, such as get blockchain info, get network info and get wallet info instead, which I can show those
So
briefly.
it wants you to upgrade to 0.16. Is that what it's saying?
It's saying when 0.16 comes out, then this command will be removed.
Okay.
Get info. So it's just there for backwards compatibility. This is what a lot of people used to use.
I gotcha. So I'd run a bitseed, which is your dummy version of your node. It's bitseed.org. I'm wondering if it upgrades automatically. I'll have to go check that.
Yeah, that'd be a good thing to see because you'd want to make sure that it's upgrading on its own. Looks like it's showing your video. So I don't know if they can actually see my screen share.
I'll turn my it's showing you.
Oh yeah, it's when I'm talking. Okay, cool. When you talk, it switches to you. That's good. That's the way we want it. So yeah, basically it'll list the version of your node, which in this case it shows 15, which is the 0.15 version. Your wallet version, the balance. If you do have a wallet stored on your node, you can actually see your balance there. How many blocks that have been synchronized, or the block height, which shows you how many blocks have been synchronized to this node. In this case, we're up to the latest block, 486849, and we can actually confirm that by going like blockchain.info and seeing if that's the latest block. I currently have 43 connections, which is the largest I've seen on mine. So it's definitely being used. So that means 43 other nodes out there are connected to me and sending me data and receiving data from me. And then the difficulty number for the network is represented by this large value. From what I remember, this is the number of times it is more difficult to mine a block versus when difficulty was 1, which was in the beginning of Bitcoin. So it's basically a shitload more difficult to mine a block.
So it's a relative number.
Yes.
But there's no units on it, right? Like
yeah, exactly. It's actually times. Like
it's a proportion.
You know,
it's just proportion to one, some arbitrary starting point.
yes, exactly. So, but every block still mined within 10 minutes. It's just the mining power throughout the globe has increased so much that the difficulty has increased this much time to keep the block time at 10 minutes.
Yeah.
Then it just tells you if you're using the test net, which I'm not at this time, and then a few other values that we're going to ignore for now. But yeah, pretty much just run a few others that it mentions quickly here. Just kind of show you are actually getting information from your node, and this is information from the Bitcoin network, which is pretty cool. This command is bitcoin-cli get blockchain info. So we're on the mainnet. This is the number of blocks, the number of headers. Here's the best block hash, which I'm not sure if that means the latest block. But you'll notice.
Well, I'll look that up while you're talking.
Yeah, yep. And so the best block hash here shows quite a bit of zeros in the beginning of it, and that's actually part of the whole difficulty calculation. So basically, as a miner hashes a block, which is a computatively difficult operation, it has to do it as many times as it requires to get this number of leading zeros. And it does that by just picking random numbers and hashing them with a block.
No, I know Andreas,
Yep.
in one of his videos, he gives you like a formula. You count how many zeros you can an estimate on how many hashing power.
Oh yeah, exactly.
There's some kind of, and that's something insane. Like I'll look that up.
That is crazy.
That's the amount of hashing power able to reproduce that many zeros is absolutely nuts.
Oh yeah, it's exponential. For every zero, it's exponentially more difficult. And as you can see, the number we saw earlier was very large. What is this? Millions, billions, trillions? So yeah, it's in the trillions.
The amount of electricity that to pull off that kind of block hash.
Yeah, it's quite a bit.
Yeah.
And that's what makes the network so secure, is because the amount of electricity that's put into it means that people have to spend real money to mine, which means that they're not willing to put that money at risk to try to necessarily attack the network. Instead, they'd rather get the rewards, which are at 15 Bitcoin per block currently.
It's just part of the perfect system. I mean, it really is so smart, like thought out, just so perfectly. Like,
oh yeah, it's
pretty cool.
And then we have the difficulty again, median time, which I believe this is going to be what, seconds, milliseconds. to each block. I'm not sure. We'll have to look that up just to make sure. But you can see, I'm not sure what the chain work is. This is the pruned. If it's true, this means that your blockchain that you sync to your machine has been pruned to reduce the amount of disk space it takes up. In this case, I'm running a full blockchain on the machine. However, you can develop against a pruned blockchain. You just won't be able to get all the information that you would like to get full. And then it covers which BIPs or Bitcoin improvement proposals have been installed or that are active. BIP 34, can't tell you what it is, but I'm sure we can provide links to that. BIP 66 and BIP 65. BIP 9 soft fork is active, and SegWit is active, which has been a lot of talk in the past month.
Woo!
Yep, many months. But yeah, it actually tells you which block has been active since. So this is a consensus rule that has been, implemented since block 481824. So basically, what I'm going to try to go through is just a couple more commands, but these are going to show you what in Chapter 3 is covered, and I'm going to just jump down to one where we can just do a Bitcoin CLI get wallet info. So if I had any Bitcoin installed on here, I have to actually spell the word Bitcoin correctly. It would show me what's in my wallet, my balance, unconfirmed balance, my transaction count, all that type of information. Another command is get block hash. Now this is kind of cool. So we can actually get the hash of any block. For example, block 1000, which was many, many years ago. And it's actually pulling this from my machine that quickly. So it's showing you that the block 1000 had a hash of this value. And you can see the leading zeros there were a lot less than the leading zeros of a more recent block, like 480000. You can see the difference there. Got 8 zeros versus, I'm just going to say 16, maybe 18 zeros there. So the difficulty has increased quite a bit. And so we can also go to a transaction using this. I'm going to do this here. We're going to do Bitcoin CLI get raw transaction. So this is a raw transaction that I selected off the blockchain earlier yesterday. And basically when I run this command with the transaction ID that I pulled off blockchain.info, we actually get the raw hex data dump from the transaction. And we will, future episodes, cover what the pieces of this hex dump mean.
Yeah, that's a full episode into itself.
Yeah, maybe several full episodes. It's quite a bit of information. Yeah, so I'm not going to break that down, but I will show you if I take this raw information and just copy it. I can do a get for Bitcoin. Here on my screen. Bitcoin CLI. We're going to do, what is it? Just want to make sure I run the right command here. Decode raw transaction, and we're just going to paste the data from that transaction. So the raw hexadecimal data, and boom, you'll see we get this long output that is mostly human readable. This is the JSON output. This basically, I hit the volume button on my microphone. I just realized my microphone is in the wrong ear. So hopefully everyone can still hear me okay. I mean, you heard me all right?
Yeah, no, we can hear you.
Okay.
I'm trying not to talk or turn my computer because it'll keep flipping to my screen.
No, it's fine.
Okay, cool.
So cool. Now I got the microphone actually up to my mouth and not on the desk. We have some human readable data that's being pulled from the actual hexadecimal data. So all this information here that you see is actually encoded in this hex value here. So you'll have the transaction ID, which is that ID that I pulled earlier, the hash of the transaction.
That transaction ID, that's what you can, if you looked up in the blockchain.info, you search that's the ID for like one of your transactions, right? That's exactly the same. Yeah.
Yep. This is just a transaction I pulled from one of the most recent blocks, probably a couple days ago. And then the hash of the transaction is actually the transaction ID. So you see these values are the same. And then
Yeah.
there's the version, which we can cover later, the size in bytes of this transaction, which is 225 bytes. The lock time, which is 0 in this case, which is basically that this transaction had to wait, or what date and time that this transaction was to be executed. And 0 meant really as soon as possible, from what I remember. Then there's another transaction ID in here, which is the actual input. So this would be, hey, I have 5 Bitcoins I want to send to Brian from my wallet. This is the transaction ID that I'm inputting into this transaction. And then there's the signature, which we, in the script sig, which we'll get into in future episodes and what all this breaks down into. And then there are the outputs. And these are the outputs saying, hey, I want to send, for example, 0.1073 Bitcoin to Brian. So here's the first output. And then here is the script pub key, which contains the information and the address that I want to send that value to, which in case, for this example, would be Brian's address. And then there would be another output in most cases, which will be the change back to me, myself. In this case, I only want to send him 0.107, and I was sending a total of maybe 2 Bitcoin, so I want the resulting change, 1.89, sent back to myself, which this address would be either my previously used address or a new address that I want to use to send my change to. Yes. That makes sense?
It did. It did. So, no, I did. It did. Now you're not. I guess you're not SegWit, right? SegWit starts with 3.
Yeah, I don't think this is a SegWit transaction.
Okay.
Yeah. And when I pulled it, I believe that there was something in there that actually told you the version number. Yeah, was different.
I guess it wasn't not always SegWit. Multi-sig wallets were started with a 3 before SegWit too, as well. If you wanted to have,
I believe that affects the
2
version
people
number.
over a wallet, like with Copay. Copay is a great app. If you want to set up a account with 2 or 3 people, where 2 of them have to approve it of a transaction. That's the whole multi-sig aspect. Copay is an awesome app. You can set them up, send a link to your buddy, and you can all share a Bitcoin address.
Oh, nice. Oh, that's very cool. I didn't know about that.
Yeah.
I have to check that out. And then we're going to jump to just another command, I believe, or command or 2, before I actually show you some neat things where we can do programmatically. So basically, I can pull a block number. In this case, the block number is 277316, and we're going to get the block hash of that number. So I think this is similar to a command earlier to get, we did this earlier with the 1000 and 4000, so that's really just a duplicate command, so you can ignore that one, but that's just another example. We can put any block number in there, pretty much any number from 1 to, 480,000 plus, and we can get the hash of those blocks. There's the block hash for the first block, Genesis block, and there's 2, 3, and so on and so forth. Until we get to the latest block. So if I put a bogus number in here that's much higher than the current blocks, we should get an error. Yep, block height is out of range, because that block has not existed yet and won't for a little while. Another command is to get the block, just get block. So we're gonna do that real quick. And then we're going to actually provide the block ID in this case. So instead of saying get block hash 4, we're going to provide this number, which is the actual hash or the ID of that block, hash ID, which in this case, when I do that, it gives us a giant list. I keep scrolling until I get to the top. And basically, this is the information from that block. This is the hash of the block, which is what I provided to pull this information. How many network confirmations it went through, the strip size or the stripe size, the size of that block, the weight, the height, version, the Merkle root, which we will get into the future about, and then all of the transactions. So these are the transaction IDs, the hashes of the transactions, or the transaction IDs of every transaction that was placed in this block and executed in this block. And it appears that there's definitely hundreds, if not thousands, in this one. And then it tells you the time it took, the nonce that was used to hash together with the block data to achieve the block hash. And then the most important pieces that I would consider that create the blockchain are the previous block hash and the next block hash. So basically, this is what links every block to its previous and future block. So in this case, the previous block hash, or the block that existed before this block, had this value. And this value is actually part of this block. And when this block is then hashed, this value is actually hashed into the new hash value, which is kind of where the security comes from. So if anyone were to go back into a previous block and change a value, it would break every block afterwards, because this hash would then become invalid, which we'll go into more in the future as well. So I'm going to go ahead and stop my screen share here, and we can show a few other things here in just a moment, but I'm going to try to get this off.
Thanks for letting me be a part of that. That was pretty awesome, Rob.
Yeah, I know. It's pretty cool to be able to actually run commands against.
I guess we have like one person to take questions. Any questions out there, guys?
Yeah. Is anyone watching? It's a lot of information, and it's really just kind of showing you, hey, you can install the node onto your machine. You can run commands against the Bitcoin blockchain without actually having to interact with the internet. I mean, you could literally be disconnected after you sync the blockchain and just run commands and explore around if you really wanted to. But the whole point is, this is the reason we synchronize everything to the blockchain onto our machine, development machine, is so when we develop scripts or applications, we want something to talk to locally to test against, to get fast, fast responses and reliable responses. Not saying you have to. You could connect to any node and test, scripts and applications against too. It's just not as reliable, and you may have a speed, or connection issue. So this is really where all the magic happens, and what wallet apps and exchanges and so on and so forth have running somewhere in some form to verify information from the blockchain, and is really the heart of most of Bitcoin development. Application development, not necessarily developing the Bitcoin core, code, but at least applications that are built on Bitcoin.
Yeah.
So in future episodes, we can actually show some really simple Python code examples. I can just show you a quick few real quick while I'm here, since I already have them pretty much loaded up, that basically do the same thing of what I just did. Those commands, let me just do here, like there's 3 examples here. Like I can do block trans add. So let's just do a cat of block trans add pi. Or let's do a nano of block trans add. I'm just loading up a text file, a Python text file that has, do that. There we go. That has some code in it from the book. So this is just some example code. I won't go into too much detail, but basically it imports a module, a Bitcoin module, that allows you to run commands against a Bitcoin node, and then it basically selects a block. In this case, it's 277,316, and then it tells it to get the block hash of this block. So basically, the code will run, grab the block hash of this block number. Then it will retrieve the block by its hash. So then it'll get the data that's retrieved, or that's part of that block. It will then build a list of transactions that are part of that block. And then it will then go through and print a list of those transactions. See, it will iterate through each transaction ID in the block, retrieve the raw transaction by ID, decode it, and iterate through each output in the transaction. So actually what it's doing is finding the outputs of every transaction, adding them to a list, and then adding them all up to say, hey, this block, which had, say, 1,000 transactions in it.
That file, is that inside the Bitcoin client?
This file right here?
Yeah.
This file is actually just Python code written by what's it called? Whoever put it in the book, maybe Andreas
Okay.
or someone else.
Okay.
This is actually just code written to interact with my Bitcoin node, pull a block out. In this case, like I said, block 277,000 something. Add up every transaction's input and outputs, which are the actual Bitcoins being sent and received, and print a list of the total value that was transmitted in this block. So that's what this line here, total value in block is block value. So what I'm going to do is just run it. And this is actually going to pull block number 277,000, count every transaction in it, every value in it, and give me the result. And you'll see how fast I can do it. Just a couple of seconds here. Boom. So the total value in that block was 10,322 and some change Bitcoin. And I could just show you if I were to go back into that file and change that to a more recent block. Or let's just have fun. Let's do a block height of 50, the 50th block, which was probably 2000.
That's Hal and Satoshi right there.
Yes, exactly. Let's go ahead and peek into there and see how much value was sent there. So if I go ahead and save this file, which by the way, this is just a text editor in Linux. You can do this in Notepad or any text editor, Windows or on your Mac. And now I'm going to rerun that script, and it shows you the total value of 50 Bitcoins.
That makes sense.
Yeah. If
that was a block reward.
Yep,
that
exactly.
was that no transaction.
Yeah, there were no transactions, just the block reward. So that means that it was just mined, and we're looking at history right here, which is kind of cool. If you're really into this stuff, this is really nerdy and really cool.
Yeah, that is kind of cool. I mean, just for the hell of it. Well, no, don't. I guess we don't know. Do like 1,000 or something.
Did 1,000, and we're still at 50.
Oh, really?
Yeah.
Do 10,000.
Nothing really happened. Let's see what 10,000 does.
Yeah, and according to Digital Gold, he just left his computer running for a while, and no one was really
50. Holy crap!
Wow. Okay, go to 50,000.
We can actually build a script to take an input, but we're not going to do that today. But we're still at 50.
Holy crap! Satoshi's got a lot of Bitcoins.
He does. Let's go to 100,000.
Oh my God.
There is no way. Come on. There's no way. Boom. There's where we go. We start seeing some money move. 103 Bitcoins. Wow.
Satoshi is sitting on a lot of Bitcoins.
So he was basically just sending mining blocks and gathering the 50 Bitcoin reward. And it was 50 back then. And then there was the halvening, which was what, in 2012?
2012.
Somewhere around there. 13, 14. I know there's two halvenings. Yeah, so there was a halvening that brought the block reward that the miners got down to 25. And then again, it went to 12.5, which is what we're currently at. But then again, the value of Bitcoin has gone up quite a bit. So, you're getting less Bitcoin, but you're getting more, value USD or whatever currency you're exchanging it to.
Yeah, I still believe that we need to start calling it by like millibits, or something like that, because there's like a unit bias that Jimmy was talking about in that class.
Yeah.
When people see a Bitcoin and they see how much it is, first off, people don't know that you can buy a fraction of a Bitcoin. But if you didn't think it's in millibits, then it'd be at first glance you see it, and it just that's affordable, But
how do you feel about the Satoshi?
I mean, if we get to a point where we have to like buy shit in Satoshis, I'm gone. I'm retired.
So 800 Satoshis would be like on my screen. We would just be like, well, let's just do 8 Satoshis. So what is it? Like that? That would be 8.
Just under $1 billion. No. Right. Yeah. 100 millions. Yeah.
Yeah. So that is the smallest unit of Bitcoin.
That's a bit. That's a bit Bitcoin.
Yep.
Satoshi. Well, whatever. Yeah.
And then real quick, I can show some other ones here. There's because these are just.
Have you seen the unit list for Ethereum? Sorry, not to digress.
Oh, what's that?
If you look sometime on the GitHub for Ethereum, the units. Like,
yes,
I've seen those. We have Satoshi. Like there's a Zabo. Like a Nick Zabo. There's Ether or something like that for each unit. They made their own units. them. It's ridiculous.
That's what's great. You create your own, you know, currency. You can come up with your own names.
Yeah.
And then I'll jump into the
Right.
script real quick. This one's pretty simple. It grabs the transaction ID, which is predefined in the script for this example. Then it is told to get the raw transaction of that transaction ID, which will be the hex. And then it's telling it to decode that transaction, which will be the JSON, human readable output that I showed earlier. And then for each of the outputs from that transaction, go ahead and print them. So it's just a really simple, get one transaction, nothing like the previous script where it got every transaction and then gives you the outputs. So if I just do get trans, it goes through that one transaction in the blockchain. It gets the addresses that those outputs are being sent to and the value in Bitcoin. So in this case, 0.015, another address, which is probably the change, or one of these is probably the change, 0.0845. So I think this is actually the amount of value that's being sent. In the example in the book, it was Alice sending to Bob like 0.015 Bitcoins for a cup of coffee, for example, and this was the change, which is actually an interesting point. These examples in the book were actually executed on the blockchain. You know, this was real money.
That's a cool aspect of the book.
Yeah, yeah. So the people are fake and the examples are fake, but the transaction IDs and the blocks that these happened in are real, and we can actually pull them on our node to test the code in the book. And then I just have one more example of the RPC, which is the remote procedure call. Basically, what makes this possible? Let's just go into Nano. Let's see what this code does. I kind of ran these backwards, but basically, if I were to exit this out and just do the RPC example and run it, it would just basically go grab the latest block height, which is the most recent block number. Which, if we just do a quick, hey guys, I'm back. How's it going? How are we doing? Do we got any views?
Just staring at your beautiful code.
Oh, thanks, man. I actually stole it from the book, so thank you, though. So is anyone watching us? Do we have
yeah, we got two. We got two. We're
I think that's us, but that's okay. So I'm just gonna do a quick share of the blockchain.info website, and you'll see the latest block is 486.849.
You're getting the repeat thing going.
That's awesome. I'm sharing the wrong screen. Hey guys, this is live television, live YouTube for you. Let's share another application. Are you ready? Boom. All right, so the latest block on blockchain.info is 486.849, and that's exactly the latest block that is on my node, which I showed you in the Python code that we ran.
Yep.
So it's like magic. It's like all this information that is living out on the internet on all these different nodes and 9,400 some odd nodes is actually accessible to me.
I guess we can probably wrap it up here soon. We got we got 6 washers now. It's something, you know, let's just say this like goes on for hundreds of more years and hundreds more years. Like you got this like what I'm trying to say, like it's a time capsule. It's like like what the Coinbase, you know what I mean? Like a message to your kids in the blockchain. Like, you know, or you can put your genome in there and maybe they'll reconstruct you in the future.
No, you can store some information and it's limited,
like,
but you can.
It does become like the future money, and like 1,000 years from now, we're still using it because we're gonna mine asteroids and they're gonna find gold. Gold's gonna become worthless.
Yeah.
What else is worth anything that has fixed value? Bitcoin.
Exactly.
But you can actually put information into that blockchain, and that's like the best time capsule ever. You know, you can write a love letter to your kids or something, or
especially if all the nodes are destroyed. If they're not destroyed, which is very, very unlikely, the information will still be out there, and I'm sure people work to preserve it, even if Bitcoin may be someday moved on past, someone else comes along, something else comes along. I'm sure they'll still preserve it.
Yeah, I see it being preserved for a long time, and it's kind of cool. I didn't think about that, but
we actually got a comment from a Corey Robinson. Shout out to him in our live chat. He just said, "Hey,
you are our first chat. You're first chat guy.
You're caller number 1. You're gonna win
free Dogecoin."
Yes, Yes, you can send it to him. So I don't have it.
We'll send you some Dogecoin. If you get, next episode, if you get on here, you message us. I'll send you some Dogecoin.
Oh yeah. Oh yeah.
Right. For being our first guy. So
I think that is pretty generous. We're just trying to, help everyone out, learn some Bitcoin, the inner workings of it, maybe develop for it, and earn some Dogecoin at the same time.
Yeah, there you go. Well, other than that, Rob,
yeah,
we almost 40 minutes here, unless
that wasn't too bad. Honestly, I mean, I know it was a lot of text on the screen, guys. And I do want to say something about that. That's really going to happen in this type of video series. I mean, we'll do other ones where there's not going to be so much text on the screen and reading and coding, but really, if you want to learn this shit, you gotta see some code. You gotta see some command line. Some of it's, a lot of it, or all of it, maybe over your head. That's okay. Ask us questions on the chat. Ask us questions in the comments. Tweet at us, whatever you want to do. And if you want more information on a certain topic, just let us know, and we'll point you in the direction. We can point you to directions of different YouTube channels that we've learned from, different resources.
Yeah, I've watched like probably 3,000 different YouTube videos.
Oh yeah, yeah. I'd say watch World Crypto Network. For especially like market information and the state of Bitcoin, and Jimmy Song. He's dreamy. You got to watch him.
Yeah, I guess we got to throw it out there. Programmingblockchain.com.
Yes,
that's where we met.
Oh yeah. My wife thinks that Jimmy Song's my boyfriend. She calls him that because anytime he's got a live broadcast, I'm watching it, or I'll be looking at his Twitter, or
Jimmy after that.
Yeah. She's like, you're obsessed with this guy. I'm like, well, I mean, he's a celebrity. He's one of the celebrities of the crypto space, and I respect him a lot, and he's really helped us a lot. He actually is the one that tweeted us out the other day, and we got 200 subscribers out of it, which is amazing. I mean, this is just episode 2, so we owe everything to him, honestly, and he's the one that really inspired us. So definitely follow him. What's that?
We're gonna tank it. It's like we're gonna just those subscribers are slowly gonna leave.
Wait a minute. Why do we only have 5 subscribers? What the hell? Wait a minute.
Yeah.
It was all that text on the screen.
I'm good. Corey,
you good?
Check, please.
Yeah, send a check. Or CHC. Is that a coin?
Yeah, there you go. I got some CVC.
Yeah.
Oh, anyways.
Civic's good. I mean, wait. Bitcoin's the only true one. No, I'm not going to do that.
I'll do a little bit of this. I said I wouldn't, but Decred, Litecoin, Ethereum. Those are my holdings, and Civic. Most 80% Bitcoin. So.
Well, right now I'm virtually crypto broke. So if anyone, I'll throw out my wallet address. If anyone wants to throw us any tips in the future, we'll throw up our wallet addresses. And we don't mind tips. It can be micro. It doesn't matter. But we're really not. Yes, exactly.
I can show you a private address right now, and you guys can't get the money out of it because the transfer fee is more than the money involved.
Yeah, I've got a few of those.
Next time, and then maybe when the price goes up, someone will steal it. So
why not?
So
CHC is a coin. BTC, CHC, LTC, and BTC are Corey's holdings. So
I don't know what the first 2 are, but
Vertcoin maybe.
Vitalik over Veritasium or
yeah, maybe. Of course, it's a Google search away, but we'll look it up.
Chocolate coin.
Yeah, chocolate coin. That sounds delicious.
Decentralized cocoa. Anyways, I'm getting a little lippy.
No, it's all right, man. Me too. We're just having fun with it. But guys, we appreciate you checking this out and watching this. We know we went a little long. We're not going to really have a set length for these videos, but
chapter 4 next time, right?
Yeah, we're gonna try to go over chapter 4, and which should be about elliptic curve cryptography, which is going to be.
Hopefully I can do more. I like math.
Yes. So I'm hoping you can handle the math part, and
hopefully I can talk on the prime fields and the curves and stuff.
Yes.
Like that, so.
Yes. And so we'll keep it interesting if we can, and we'll try to throw some nice diagrams on there, and we'll also send you some links to other resources because we're not going to be able to fit everything in the video. But all right. Well, I appreciate everyone watching.
Rob.
Yeah.
Good show, buddy. Thanks,
Yeah,
man.
you too. No, thank you guys. Until next time.
All right.
Talk to you guys later.
Later.
Bye.